This is cheap power bank from. I get some recording issues because I ran out of space and everything best was not recorded, including breaking my Chinese pager. But basically, these battery cells are unknown because I don't know this brand. These are not LG and these are not Samsung. And better thing what I found is this connection is open. This cell is not connected, and that's mean 1, 2, 3, 4. Only 4 cells are connected. And specification for this power bank is, you can read this. If you want to pause, you can pause it to read this. But that's mean basically these specifications is wrong because this cell is not connected. Yeah. By quality, board looks basically okay because they wash off all flues and I cannot see strange issues with that. But okay, ground connection. Now I want to understand how they connected USB sockets in this, because by now it looks like they connected. Yeah, this goes there. Yeah, they connected all sockets in series. This is shitty practice. Now you can see it's half charged, but yeah. Now I want to know, is this cell charge connected? No. Oh, with double click you can turn on backlight. How to turn it off? Double? Yes, double click. Yeah, but basically quality is very cheap. Only question is, can I reuse these cells for other projects? Maybe. About casing, you can see it's clipped here. And basically that's all. And battery cells were glued with this double-sided tape. For circuit board there was some clip for connecting it, because anybody don't want to circuit board swapping in breeze. And basically that's all. About real power we need to check it out, but yeah, basically I very how to say that shit,
crappy.
No. Okay. I believe that this power bank can bring 1 amp from charging current for output, but how they can put 2.1 amps on other socket, because these sockets looks like they are connected in parallel. Why? How? This is not possible, because if they indeed connected in parallel, you cannot bring for one socket 2.1 amps if other sockets had only 1 amp. How this possible? It's not possible. Or they mean that if you using just one connection you can get 2.1 amps, and if you using every connection you can get only 1 amp, maybe, but yeah. Now we just playing. First check is to ensure that there is nothing coming out from these sockets, and there is nothing. I hope this is ground because it looks strange. No, yeah, this is ground. Okay, that's mean we can check out positive connections. This mean it's need to go here. Yep, and it's going here. Okay, it's something strange because it's now turned on. Maybe I push it too hard and my multimeter didn't like it. Maybe it's now on. 5 volts, sorry. Nope, it's not on. It's only on because I just pushing with multimeters, and yeah, basically these 3 sockets are connected in parallel. Yeah. Shit. I just break this connection, but that's okay. My now question is these cells equal or not? First cell. Bye. Wait. First cell. No connection. I cannot. I don't see what I'm doing. First cell. 3.5. Disconnected cell. 3.5. It's okay. These cells, which are now disconnected, 3.54. Yeah, it's basically very close. And by design, yeah, they put this small wire because they need to put cells like this, and that's yeah. I think this wire is too small for, and it's strange, but from what they made this wire?
What material?
Yeah, it's not feel like copper. Strange. It's very strange. These wires. And what I noticed is that they crank this wire between cases parts because there are markings. Yeah.
This could literally cut off the connection.
About cutting off connection. Okay. This is what we need to do with cheap power banks. Now I want to understand global set parameters for these cells and what's manufactured them, and what can we reuse them, because it's very cheap indeed. This part maybe we can reuse these, but yeah, by now I don't know where I can put it because it's too cheap to yeah. Sockets is good. Some SMD resistors, I can reuse them. Button is good. In remote controls, sometimes these same buttons. And this IC, it's don't have any markings because they probably sand it. This chip had markings. It's marked as 2M04. I don't know this chip, but this probably is not chip. This is okay. What can it be? It's not for maybe it's some transistor, but because it's have too many outputs, it's strange. Yeah. And there are some different ICs. Yeah, it's interesting. But probably this one is microcontroller. Yeah. And basically this power bank was using old micro B connection for charging, and how I think it's absolute. Yeah, that's mean we can reuse cells, and maybe for future projects I can purchase more cheap Westrom power banks from Maxima just for cells.